You think clearing your cookies makes you invisible? It doesn't, not even close. Your browser leaks hundreds of invisible details that combine into a fingerprint as unique as your actual fingerprint. Today I'm breaking down every single way your computer is tracking you, starting with the most sophisticated silent method operating right now: browser fingerprinting. Every time you open a website, your browser silently blurts out hundreds of attributes: screen resolution, installed fonts, time zone, color depth, HTTP headers. Individually, they're useless. Combined, they create a quasi-unique identifier, and clearing your cookies does exactly zero to stop it. Here's where it gets weird. Sites use APIs like Canvas, WebGL, and Audio Context to make your GPU render hidden graphics or process silent audio. The resulting pixels and waveforms vary based on your exact GPU model, driver version, and font rendering. On desktop, this achieves 99.24% uniqueness. Like, you are one in millions. Commercial anti-fraud systems take this further. They build cross-layer profiles combining your TLS fingerprint, HTTP two-frame behaviors, and JavaScript properties. If you spoof Chrome's headers but emit OpenSSL-style TLS handshakes, you're instantly flagged as fake. And forget ever escaping. Storage APIs like IndexedDB and service worker caches persist identifiers indefinitely with zero automatic expiration, enabling ever cookie-style tracking that survives even the most aggressive scrubbing. But if you think your browser leaking your GPU is creepy, wait until you hear how websites used to track you through your battery status API tracking your battery percentage is spying on you. The HTML5 battery status API was built so websites could save your power, dim the screen, defer downloads, that kind of thing. Sounds helpful. And the W3C, the people who write web standards, claimed this battery info had minimal privacy impact. Turns out, no. A website can read your battery level and estimated discharge time without ever asking for permission. No pop-up, no warning, nothing. And when you combine those two numbers, you get roughly 14 million possible device states. 14 million. That is more than enough to create a fingerprint. Researchers proved that if you visit a site, clear your cookies, switch browsers, or even jump into incognito mode and then revisit that same site within 30 seconds, your battery state is nearly identical. The site simply matches the numbers and respawns every single tracking cookie you just destroyed. Your battery literally resurrects the exact identifiers you manually deleted, which is, not ideal. But at least your battery can't physically track your movements, unlike the sensors already built into your phone. Your phone's motion sensors know when you're asleep, not through your camera, not through your microphone, through tiny invisible movements. Accelerometers and gyroscopes stream dozens to hundreds of samples per second, encoding everything from your walking gait to your typing rhythm to literal breathing pattern. Algorithms detect whether you're sleeping, walking, or riding in a car with over 90% accuracy, zero GPS required, zero camera access needed. Legitimate uses like screen rotation and gaming exist, sure, but apps like Facebook and TikTok quietly harvest this data to monitor your scroll speed and physical handling behavior, which is not ideal. But here's where it gets dark. Manufacturing tolerances create unique calibration errors in every single sensor. These imperfections form a 6-parameter hardware fingerprint accessible via JavaScript with zero permission prompts. It survives factory resets, it survives OS reinstalls. Unless you physically swap the hardware, your phone's tiny factory defects tag you forever. But if you think invisible motion tracking is creepy, wait until you hear about ultrasonic cross-device tracking. Your TV is literally talking to your phone behind your back, and you can't hear a word it's saying. Ultrasonic cross-device tracking, here's how this nightmare works. Advertisers embed ultrasonic audio beacons into TV commercials, web videos, and even store speaker systems. These beacons play at frequencies above 20 kHz, completely inaudible to human ears. But your phone's microphone, it hears them perfectly. When you grant an app microphone access for a voice feature or a video chat, That same permission lets it listen around the clock for these silent signals. The app detects the inaudible ping, matches it with whatever ad is playing on your TV, and quietly reports back to a third-party server that you, specifically, were sitting on that couch watching that exact commercial. Researchers found 234 Android apps packed with code from Silverpush, Shopkick, and Lysanar doing exactly this. Zero disclosure to the user. The FTC sent warning letters about it back in 2016, which obviously fixed the problem forever. Turns out, no. The practice persists anywhere microphone access and ultrasonic SDKs coexist, and here's where it gets dark. Retailers place these beacons in physical stores for indoor location tracking. Even worse, this technique can de-anonymize Tor or Bitcoin users by linking your supposedly anonymous network activity to the physical phone that just heard a beacon. Your identity silently broadcast through the air. But even if you mute your TV, your hardware is still screaming its presence to every Wi-Fi network nearby. MAC randomization. Your phone's Wi-Fi chip has a 48-bit serial number called a MAC address. It used to be permanent, burned into the hardware at the factory. Retail stores exploited this hard installing sensors to log every phone that walked past, tracking your foot traffic and repeat visits. You could walk into a mall on Tuesday and again on Thursday, and they knew it was the same person, so regulators forced Apple and Google to fix it. Now, modern phones randomize their MAC address per network. Huge privacy win, right? Here's the thing. That randomized MAC is basically a disguise, a very thin one. The moment you authenticate onto a network, that network can still see your randomized MAC, your IP address, and your login credentials. But wait, it gets worse. Researchers demonstrated side-channel attacks that can completely de-randomize your address. One attack exploits Wi-Fi allow-list behavior, probing whether a device recognizes previously paired networks and watching how it responds. Another uses clock skew, tiny imperfections in your hardware's timing that create a unique fingerprint in your beacon transmission. Your phone literally has a detectable accent. So no, MAC randomization does not make you invisible. It stops random sensors in a mall from building your commute history. But the network operator and anyone sophisticated enough to listen for timing leaks can still track you just fine, which is, not ideal. And if you think a leaked hardware ID is bad, wait until you see what your photos are silently broadcasting. Every photo you take with your phone secretly writes a diary entry about exactly where you were and when you were there. It's baked directly into the file, invisible, and anyone can read it, starting with the hidden data inside every single picture you take. Metadata. In EXIF files, every digital photo carries a hidden passenger called EXIF data, camera make, model, lens, exposure settings, and the exact timestamp down to the second. But here's where it gets complicated. If your phone's geotagging is enabled, it also embeds the precise GPS coordinates of exactly where you were standing. You post a cute vacation selfie, you might as well be handing out your home address. And extracting this data takes zero hacking skill. Sites like Pic2Map let anyone upload a JPEG and instantly plot the capture location on a map. Literally anyone, which is, not ideal. High-profile investigations have used EXIF timestamps and GPS tags to track targets' homes and verify exactly where an image was taken. Now, some platforms strip GPS data on upload, but desktop file sharing and email, they often preserve the full metadata package unless you explicitly remove it. And no, resizing or screenshotting does not clear it. That metadata copies right over. Disable geotagging in your camera settings or use a stripping tool because your photos are snitches. But even after you strip the file clean, your network connection is still shouting your location. Your IP address is the one identifier you literally cannot avoid revealing online. Every single connection you make broadcasts it, and geolocation databases have been mapping those numbers to physical locations for over 2 decades. Services like MaxMind and IPGeolocation.io maintain massive databases that can pinpoint your country with over 95% accuracy and frequently narrow you down to a specific city, ISP, and approximate latitude and longitude. But here's where it gets complicated. That same IP address also ties together every session from your household. If you have a static IP, servers can correlate your browsing across months or years, linking every device sharing that router into one neat profile, which, is not ideal. And despite what a lot of people believe, incognito mode does absolutely nothing to hide your IP. Zero. It only wipes local cookies and histories. Your ISP and every server you connect to still sees exactly where that request came from. VPNs and Tor can obscure your real IP, but here's the kicker. Many geolocation services now actively flag VPN and Tor exit nodes. Plenty of websites treat those connections with extra scrutiny or block them entirely. But if you think IP tracking is uncomfortably precise, wait until you see what your Wi-Fi is secretly broadcasting about your exact location. Wi-Fi positioning systems, your phone knows exactly where you are, even when GPS is completely off. Every Wi-Fi access point around you is constantly shouting out a unique identifier called a BSSID, and your device is listening to all of them. By measuring the signal strength of nearby access points, Wi-Fi positioning systems can pinpoint your location down to sub-meter accuracy indoors. That is better than GPS, which basically gives up the moment you walk into a building. Google and Apple built their massive location databases by having every smartphone silently map BSSIDs to GPS coordinates. So your phone literally turned the world's Wi-Fi infrastructure into a global tracking grid, which is a fun side quest for a mapping. But here is where it gets invisible. Android has a Wi-Fi scan only mode that allows background scanning for location, even when Wi-Fi connectivity is completely disabled. You turn Wi-Fi off, your phone keeps scanning. Any app logging visible BSSIDs over time can reconstruct your movement patterns, your home, and your workplace without ever asking for your location. But if you think your OS only phones home when you explicitly ask it to, wait until you hear about telemetry and OS heartbeat. Your phone is talking about you behind your back, even while it sits completely untouched on your desk. A stock Android device contacts Google servers roughly 340 times a day, shipping out about 1 megabytes of data. An idle iPhone hits Apple 52 times daily, sending 42 kbytes. Both do this while you do absolutely nothing. Turns out your operating system is the ultimate insider, seeing everything before any app even gets a chance. This telemetry includes device IDs, location data, IP addresses, installed apps, and crash dumps. Sometimes it includes actual content like memory snapshots or typed text. Windows is just as thirsty. On Home and Pro editions, the basic diagnostic level is mandatory with zero opt-out. It sends hardware info, app versions, crash dumps loaded with memory fragments, and your Edge browsing data. Vendors love claiming this data is anonymized, but Apple just paid a $95 million settlement because Siri recordings, supposedly processed on device, were uploaded and listened to by contractors. They contained identifiable medical and personal information. Even health API data gets funneled straight to insurance programs. You can toggle some settings to reduce this, but there are hard floors. You can dial it down, but you cannot turn it off. And if you think your operating system is nosy, wait until you see what your inbox is doing. Email tracking pixels. Read receipts, those little notifications that pop up asking if you're cool with someone knowing you opened their email. Tracking pixels are the exact same thing, except they never ask permission and you can't see them. Turns out roughly 70% of all marketing emails contain a single transparent 1:1 pixel image that loads directly from a tracking server the instant you open the message. When your email client fetches that invisible image, the server logs everything. Your IP address, the exact timestamp, your user agent, which reveals your specific device and operating system. Every single open event fires automatically with zero prompts. And here's where it gets dark. Each pixel URL contains a unique recipient ID, meaning senders aren't just learning that someone opened their email. They're learning exactly where you were when you opened it, thanks to IP geolocation. Open enough emails and they've built your complete location history, your daily commute, your home, your work. They also see every time you switch devices because your user agent changes, enabling cross-device fingerprinting. Link tracking wraps every URL in redirect domains that log your clicks, which, combined with pixel data, feeds SendTime optimization AI that literally learns what hour you're most likely to read messages. You don't even have to click a single link. Just opening the email leaks your data, which is, not ideal. But if you thought your inbox was watching you, wait until you see what your internet service provider is quietly logging every single time you type a URL. DNS is basically the internet's phone book, and it records literally every conversation your device tries to have. When you type a site name, DNS translates it into an IP address, which means your DNS resolver sees every single destination you attempt to reach. Yes, even in incognito mode. Your ISP logs these queries anyway because incognito only hides your local browser history, not your network traffic. So to fix this, we got DNS over HTTPS and DNS over TLS. These encrypt your queries so your ISP can't read them. Problem solved, right? Turns out, no. Even with encrypted DNS, the TLS handshake includes a field called Server Name Indication, or SNI, which broadcasts the host name in completely readable plain text to anyone watching the network. Wireshark demos show you can see exactly which site someone visits just from the SNI leak, encrypted DNS and all. Encrypted Client Hello would fix this by encrypting the SNI entirely, but it breaks corporate monitoring systems that rely on seeing that data, so adoption is painfully slow. And here's the clever twist. Trackers use something called CNAME cloaking, where a first-party subdomain secretly points to a third-party tracker domain. Content blockers see the first-party name and let it right through, completely bypassing domain-based rules, which is, not ideal. But if you think your network traffic is exposed, wait until you see the permanent hardware serial numbers burned into your devices. Your phone has a serial number burned into its hardware that it carries for life, and someone built a fake cell tower just to read it. Hardware serial number ID. The IMEI is a 15-digit code permanently assigned to your mobile device. It never changes. The IMSI lives on your SIM and identifies you as a subscriber. Carriers use both combined with cell tower triangulation to pinpoint your location. But here's where it gets dark. IMSI catchers, commonly called stingrays, mimic legitimate base stations. Your phone connects to the stronger signal automatically, and the catcher vacuums up every SIM ID in range while intercepting calls and data from everyone, not just targets. Cool. Add that to the civil liberties violation list. Android 10 fought back, restricting hardware ID access to privileged apps only. Google now pushes resettable Firebase installation IDs and the Play Integrity API for fraud checks instead. Hardware attestation systems use secure enclaves to prove your device is legitimate without leaking raw serials, which is, not ideal when those attestation tokens can still link your sessions over time. No single identifier dominates modern tracking. It is the fusion of 100 weak signals into one robust profile that defines the system. Your IMEI is the ultimate anchor, but it is just one thread in a massive net. If you enjoyed this video and want to see more, click the video on the screen now.